kind of dovetail from the last presentation. Think back to the last time you were sick, the last time you had an infection keeping you out from work. You might have felt anhedonia, that is, a loss of pleasure associated with activities you normally enjoy doing. In other words, a loss of both motivation and reward. But in addition to temporarily feeling under the weather, these observations may provide a window through which we may examine a societally much larger issue, an issue afflicting over 9% of the population aged 12 and over and costing our nation almost $200 billion per year. I speak today of illicit drug abuse. For my dissertation, I study a brain structure called the nucleus accumbens. This is located deep within the brain and is responsible for integrating information, both motivation and reward. Again, think back to the last time you were sick. Importantly, this structure is altered by virtually all drugs of abuse, including cocaine. The nucleus accumbens is made up of brain cells called medium spiny neurons. These cells communicate with other brain regions as well as between themselves through connections called synapses. Drugs of abuse are thought to cause dependence and addiction in part through altering synapses within the nucleus accumbens. Unfortunately, we still don't know many of the details underlying how. This is my research question and stands as the major barrier to develop effective therapies. We know that infections in the immune system affect motivation and reward. I use mice to see how certain molecules associated with the immune system affect cocaine reward learning, as well as the strength of synapses within the nucleus accumbens. More specifically, I'm examining a protein called toll-like receptor 4, or TLR4. TLR4 is used by the immune system to detect and respond against bacteria, as well as other harmful things that should not be found in a healthy body. I gathered data showing that if you remove TLR4 from mice, they get an attenuation in the rewarding sensation of cocaine. I also found that both activation as well as removal of TLR4 causes alterations within the strength of synapses within the nucleus accumbens. What remains to be seen are some of the fine details underlying the specific downstream signaling cascade within this brain region. In addition to increasing a fundamental understanding of the brain, work from my dissertation may help unravel novel therapeutic targets that we may use to combat drug abuse and drug addiction. Whether you're taking drugs because you're sick or sick from taking drugs, remember that these two processes may have more in common than previously thought. TLR4 and the immune system may be what links these together. Thank you.